I get that mass energy equivalence is a bit hard to wrap your head around, but we have, unfortunately, a kind of depressing example that we've seen in the real world. Nuclear bombs. Strap in. The act of nuclear fission converts some of the mass in the nuclear material to energy. And remember, E equals mc squared. Energy equals mass times the speed of light squared. Now, the speed of light is huge, and the speed of light squared is really huge, which means just a very, very tiny bit of mass can create almost unfathomable amounts of energy. The atomic bomb dropped on Hiroshima released approximately the equivalent of 0.7 grams of mass turned into energy. 0.7 grams. A paperclip weighs about a gram. That much chaos and destruction can come from that little matter. It's weird, it's depressing, and it makes your brain hurt, but it's a fundamental law of the universe. In a way, the only thing that exists in the universe is energy. It's just that sometimes that energy is bundled up into mass. Like, there is energy in the strong nuclear force that holds quarks together to form particles like protons. And that energy is always there, always holding those things together. So you need a lot of energy to just allow mass to exist. And this is why matter-antimatter explosions are so terrifying. Because in the case of a nuclear explosion, it's actually not efficient at all. Nuclear fission loses a lot of energy in weird ways. Like, you actually needed a lot more than the mass of a paperclip to get the explosion that the bomb dropped on Hiroshima created. But if matter and antimatter annihilate, all of that mass becomes energy, all at once. A perfectly efficient energy conversion. Which means if most of a paperclip encountered most of an anti-paperclip, it would create an explosion the force of a nuclear bomb. It would mean that an amount of matter that you would have to see with a microscope would be as powerful as a conventional bomb. And it would mean that matter the size of an actual bomb is kiss the entire Earth goodbye. Mass energy equivalency is a kind of terrifying thing. But if you're not thinking of bombs, and I guess I'm sorry for making you think of that, but if you're not thinking of bombs, it's kind of a wondrous thing. Because, again, it tells us a really interesting and really weird fundamental law of our universe. Which is to say, everything is just kind of energy. It's just sometimes that energy is bundled up into mass, and sometimes that energy is out doing other things.